try to discover a little something to make me sweeter. Oh, baby, refrain from breaking my heart. I'm so in love with you.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And yes, I am so in love with you, calculus. This is increasing and decreasing functions part 2. So we left off where we were talking about the intervals where this particular function was increasing and where it was decreasing. And we have a little tool here that is very, very useful to tell us when a function is increasing or when it is decreasing. And it is called a sign diagram, S-I-G-N, not the trig sign, a sign diagram, okay? So we are going to make a sign diagram to tell us when this function is increasing and when it is decreasing. So where does the increasing and decreasing change? Well, it changes when x is equal to -1, so I just put a little tick mark there, and when x is equal to 2. Okay, and we said from -infinity to -1, the function is increasing, so we will represent that with a positive sign. And then between -1 and 2, the function is decreasing. And then to the right of 2, or from 2 to infinity, it is increasing again. So this is a very nice little tool that you will be using quite a bit in this unit and with calculus as we move forward. And again, that's called a sign diagram. Notice that it's decreasing all the way on that interval and decreasing. Did I say decreasing? It's increasing here and then decreasing on this interval and then increasing. Okay. What's next? Well, we're going to take a look at some functions and we're going to make sign diagrams, but we're going to first take a look at them on our calculator. So let me go back to that. The first function we're looking at is f of x is equal to x squared. So I've graphed that on our calculator and I've drawn a tangent line, and I have here, let me get this out of the way. I am measuring the slope of the tangent t, and right now it's at -1.19. And I think we can all agree, just from what we talked about last time, that x squared is decreasing from -infinity to 0. Just think of the man walking down here. It is decreasing, 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 decreasing until we get to 0, and then it's increasing, 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 increasing. So I'm going to move the tangent line, and while I'm moving it, I want you, in fact, I'm going to move this maybe, I guess, yeah, I'll just move it here, a little bit easier to see maybe. I want you to keep an eye on the slope of the tangent to the curve, the slope of the tangent line, as I move it. So, okay, so right now the function is decreasing, and I'm moving the tangent line along the part of the graph where it is decreasing. And what do you notice about the slope? What do you notice about the slope? It's going to be 0, okay? And now the function is going to start increasing. Okay, you might be trying to watch the numbers, but that's not really what we're after. What we're after is the sign, S-I-G-N, of the slope or the gradient. Look, as the function is decreasing, the sign is negative. It is negative until it hits 0, yes. And then when the function is increasing, the sign of the slope of the tangent is positive. So the slope of the tangent to the curve is negative for all values of x where the function is decreasing. And then it's positive for all values of x where the function of x is increasing. Okay? And the slope we find by taking the derivative. So we can take that a little bit further, and we'll get to that in just a second. So we'll go back to our handy dandy little diagram, and we'll make a quick sign diagram here. It changes at 0, and it was decreasing to the left of 0 and increasing to the right, and so we have a nice little sign diagram there. And notice that it changed at 0, at the point 0. And what was happening at 0? Let's go back to the calculator. At 0, the slope was 0. It was equal to 0. Okay. Let's try the next one, which was negative x squared. And here we go. Oh no, I want to go back actually. I'm just going to change this up. I'm sorry about the delay. I don't know why it's being slow. Okay, so now I'm going to change this to negative x squared. Okay, my tangent is still there, right? And we have the same phenomena here. It's increasing and the slope is positive. Then the slope becomes 0 and it changes. And the slope becomes negative and the function is decreasing. So the derivative is negative, the function is decreasing. The derivative is positive, the function is increasing. So we go back and make our little sign diagram. Again, it's changing over at x equal to 0. So we put that there, and let's see, increasing on the left, to the left of 0, and decreasing to the right of 0. Okay, and let's take a quick look at x cubed. Okay, so let me change this out, get rid of the negative, and we'll make this a 3. And there we go. So there's our good friend x cubed. Okay, so let's see, the slope is positive, 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 positive. It goes to 0. And it's still positive. And that makes sense because if you're thinking of the walking man going from left to right is continually walking up along this graph, which gives us a sign diagram like this. Now you still put your mark at 0 because the slope was 0 when x is equal to 0, and it was increasing to the left of 0 and to the right of 0. And finally, we'll take a look at this guy, x cubed minus 3x plus 4 on the graphing calculator. So that was, let me fix this. Let's see, x cubed minus 3x plus 4. There she goes, okay? And we'll start over here. Okay, so positive, the function is increasing. Then the slope becomes 0. Let me get the coordinates of that point. At when x is equal to -1. You see how that's a -1 right there? Okay. And then the slope is decreasing, or is negative, I'm sorry. So the function is decreasing. And then we're going to have a turn again. The slope becomes 0. Let me see if I can get it. Oh, it's tricky, tricky, tricky. Oh, I got it. And let's see, the slope is 0 when x is equal to 1. It just doesn't say 0. It's going into scientific notation. And then when the function is increasing, the slope is positive. Okay, so we'll go back to our sign diagram again. And where were the turning points? Where did the graph change from increasing to decreasing or the other way around? Well, that happened at -1. In other words, the slope of the tangent to the curve was 0 at -1 and also at 1. And to the left here, we were increasing. Between -1 and 1, we were decreasing. And to the right of 1, we were increasing. And we have a nice little sine diagram there. So that's real important because I didn't want you to think that the change in increasing or decreasing always occurred at 0 like in these basic functions. You can see it can occur anywhere for any value of x. Okay, so moving forward, this is the last one that we had here. Let me just go back so you can see it. I just transferred this to this page. So we should know now with the tangent lines and the slope of the tangent line and knowing that the derivative gives the slope of the tangent to the curve, we can determine intervals where a curve is increasing or decreasing by considering the derivative on the interval in question. So f of x, the function, is increasing on the interval s when the derivative is greater than or equal to 0. And it's strictly increasing when it's only greater than 0. You don't have to worry about that. That's just being very specific and careful. And that's the whole thing about the beginning and the end of where a function is increasing and decreasing because of the equal sign. And it's decreasing, a function is decreasing when the derivative is less than 0, when it's negative. Okay, so think about the slope of the tangent to the curve here is positive, positive, positive. I'll draw one. It's a positive slope here, and the function is increasing on this interval. If I draw a tangent here, that's a bad tangent, but you get my idea. The slope of this tangent is decreasing. The derivative is negative. The slope of the tangent is negative, I should have said, and the function is decreasing. And then if I draw a tangent here, the slope of the tangent to the curve is positive and the function is increasing. Okay, that is it for now. We will move forward to part 3. See you next time.